Kia ora, Year 12. Here's question 6 from the stats paper from May of this year. I'm going to go quite quickly through this one because it is pretty straightforward calculus one, and it's dealing with a probability density function. So we're given the time in minutes taken by people to finish off a test, and this is the PDF, so we have to do all of the usual things. The first thing that we have to do is to show that k is equal to 10. So we're going to use the fact that we're dealing with a probability function. Since f of x is equal to a probability density function, we know that the area under the curve must equal 1. So that gives me k times the integral from 10 to 5. This must equal 1. Now I'm not going to do this in just one step, so we're just going to go back a bit. Right. So this is x to the negative 2 dx is equal to 1 over k, negative 1 over x. Between the integration limits of 10 and 5 will give me 1 over k. So that gives me negative 1/10 minus negative 1/5 is equal to 1 over k. Remember that you're doing a show that question, so you really want to make sure that you do put all of these steps in. So that gives me negative 1/10 plus 2/10. 2/10 is equal to 1 over k. 1/10 is equal to 1 over k. And finally, k must equal 10 as required. All right, the next question is a follow-on from that. It's to find the expected value of x. Right, so again, show that e of x is equal to 10 log 2. Well, e of x in a random variable is x times f of x dx. And my limits here are from 10 to 5. So notice that I'm not jumping through to 10 over x, right? I'm just showing the reader exactly what I've done. So 10 over x dx, which is equal to 10 times the natural log of x. You could take the 10 out, of course, but I haven't bothered. So 10 log 10 minus 10 log 5, which is 10 So my final answer is equals 10 log 2 as required. All right, we've got 2 more parts to this question. The next one is to find the probability that x is greater than 9. So integrating gives me this. Which works out to be negative 1 plus 10 over 9, which is 1/9. And there's one last part here, which is where I'm asked to find a, where we've got the probability of x being less than a is equal to 0.6. So here we're trying to find one of the limits of integration. So the probability of x being less than a is equal to this. So my bottom limit is 5, and my PDF is 10 over x squared times dx, and we know that that must equal 0.6. So we can say 10 times negative 1 over x between the limits of a and 5 is equal to 0.6, giving me this negative 1 over a minus negative 1/5 is equal to, dividing through by this gives me 0.06. So negative 1 over a is equal to 0.06. And I'm going to subtract this from both sides. This is negative 0.2. So negative 1 over a is equal to negative 0.14. Now, you're probably in shock that I've gone into using decimals, but sometimes I will. And we've got 1 over a is equal to, well, what's that? 14 over 100, which is 7 over 50, giving us the answer of a equals 50 over 7. Okay, so that's all for question 6. One question to go, and then I'll come back and do some pure papers.